Welcome to Ask and Learn.
We are asked to construct a deterministic finite-state automaton that recognizes the set of all bit strings that contain an even number of ones. So this can be represented as all strings in the set S, where S is the set 1, 1, star. And let S0 be a start state. Now, let's break this into some cases. So consider the empty string. The empty string has 0 ones, so it follows the empty string is in S, and therefore we have that since we remain at S0, if our input is the empty string, S0 is going to be a final state. Okay. And now let's consider another state. So S0 represents that there were an even number of ones. In the previous bits. And S1 will represent the fact that there were an odd number of ones in the previous bits. Now let's think about the transitions. So suppose that the input is a 1. Then we're going to move from S0 to S1. Because we started out with an even number of ones, and so now we're increasing by 1. This becomes an odd number of ones. And then suppose that this is the input is 1 at S0. Now suppose that the input is 1 at S1. Then we're going to move from S1 to S0 because if we were at S1, that means we had an odd number of ones. So if we add another 1 to that, that's an even number of ones. And finally, suppose that the input is 0. In this case, the number of ones is not going to change, so we're going to remain at the current state.